we got a really ugly integral here today. We have the integral from 0 to 2 pi of arc cosine of sine of x dx. Now, it's not that pretty, but I'm going to walk you through. So the first thing I did here was I did integration by parts. So what we're going to do is we're going to take the derivative of everything in the integrand, so arc cosine of sine x. We're going to integrate just one. So integrating one, we're going to get x, and taking the derivative of arc cosine of sine x. So remember, if you're taking the derivative of arc cosine of something, you're going to get negative 1 over the square root of 1 minus that something squared. Now in this case, that something that's inside the arc cosine is sine x. So we're going to put sine x inside of this squared term here. And remember chain rule, we have to multiply by the derivative. So instead of a 1 in the numerator, or a negative 1 I should say, we're going to have a negative cosine x. Now the first part of our answer is x arc cosine of sine x right here. But don't forget, this integral has bounds, so this has to be evaluated from 0 to 2 pi. And then we typically subtract, but remember we have a negative and a negative here. So we're going to add this whole bottom part row as the next part of our answer. So plus the integral of x cosine x over square root of 1 minus sine squared x dx. And remember, we still have bounds, so this integral will also be from 0 to 2 pi. Now this integral is what causes the complication, so we're just going to plug in these bounds first, get an answer over here. So plugging in 2 pi first, we're going to get 2 pi arc cosine of sine of 2 pi. And then now, then you subtract, subtract putting in 0. So 0 times all this, but because it's 0 times all that, it's just going to go to 0. 0 times anything, 0, so we don't have to worry about plugging in 0 in this case. So simplifying this part, we can simplify sine of 2 pi. Sine of 2 pi is 0, so we're going to be left with 2 pi arc cosine of 0. Now, notice this is arc cosine of 0, not cosine of 0. So we're not going to have an answer of 1 in for this arc cosine part. Arc cosine of 0 means what value of cosine gives us 0, and that's going to be pi over 2. So we're going to have 2 pi times pi over 2, and that's just going to simplify to the 2's cancel, so we're going to be left with pi squared. Now this is the first part of our answer. That's the answer to this first half of the integral, the first part of by parts. The big issue comes over here with the integral from 0 to 2 pi of x cosine x over square root of 1 minus sine squared x. Now this integral can be rewritten. We could first rewrite it using trig identities. So we know this 1 minus sine squared x, that is cosine squared x. So we're going to rewrite that in there. So x cosine x over square root of cosine squared x dx. And now what we really want to do, we really want to cancel the square root and the square, because then we'll just be left with cosine x over cosine x, and then we can cancel the cosines, and then we're just integrating x. And yes, we can do that, but we have to do something else first. We can't do it as it is, because the value a square root gives you has to be positive. Cosine x is not always positive from 0 to 2 pi. So for cosine x, just a number line here, from 0 to 2 pi, the two places it equals 0 are at pi over 2 and 3 pi over 2. Essentially, if we were to think of this in quadrants, pi over 2, 3 pi over 2, with 0 and 2 pi over here, so I'm just going to write pi right here. So these are the two places it equals 0. In terms of quadrants, we know that cosine is positive in the top two quadrants, or not the top two, my bad. The right two quadrants, that's where cosine is positive, and it's negative on the left two. So what we're going to have to do is, because we can't just cancel the cosines because it's not always positive, what we're going to have to do is we're going to have to split it into 3 different integrals. The first one's going to be 0 to pi over 2, because cosine is positive over here in the first quadrant. We're going to have to split one from pi over 2 all the way to 3 pi over 2, and then we're going to have to do one from 3 pi over 2 to 0. The one from 0 to pi over 2 and the one from 3 pi over 2 to 0, those integrals are going to be completely fine due to the fact that they are both positive as it is. The integral that is from pi over 2 to 3 pi over 2, because cosine returns negative, what we're going to have to do is subtract the values of that integral. because we're subtracting it, that cancels with the negative values of cosine, and it's going to give us a positive value. So I'm going to erase this. And remember, we're just canceling the square root and the square, and then the two cosines. We're just having to, this last integral of x, we're going to have to split it into those three different regions. So we're going to draw a line to separate from this stuff. So the first one, as I said, would lead from 0 to pi over 2 of x dx. And then subtract the integral from pi over 2 to 3 pi over 2 of x dx. Remember, we're subtracting because this is where the cosine was negative, so we can't cancel it unless the whole integral is negative. And then we're going to add the integral from 3 pi over 2 to pi over 2. Or not to pi over 2, to 2 pi, my bad, of x dx. Now, integrating x on its own is easy. It's just x squared over 2 for all of these. And then we're just going to plug in on this one, 0 to pi over 2. This one is 3 pi over 2 to pi over 2. And this one over here is going to be 2 pi, 3 pi over 2. I just realized I just wrote three expressions without the sign, so subtracting this one, adding this one. Now, plugging in our stuff here, I'm going to leave it in the expanded form. So we're going to have pi over 2 squared over 2. And then I don't have to worry about plugging in 0 because 0 squared is 0. We're going to subtract doing 3 pi over 2 squared over 2 minus pi over 2 squared over 2. And over here, we're going to add 2 pi squared over 2 and then minus 3 pi over 2 squared over 2. Beginning to simplify this, pi over 2 squared is going to give us pi squared over 4, and because it's all over 2, this will turn into pi squared over 8. Now minus 3 pi over 2 squared will give us 9 pi squared over 8. And then minus, remember, pi over 2 squared over 2, we already said that's pi over 8, so we just plug that right in. Over here, plugging in, we have 2 pi squared over 2. That is going to give us 4 pi squared over 2, essentially just 2 pi squared. And while it is just 2 pi squared, all our denominators are 8, so I'm going to rewrite it as 16 pi squared over 8. That way, we can actually combine all the denominators, or they'll have a common denominator, we can combine all the terms. Yeah. Then lastly, 3 pi squared over 2 squared, or all this term, whatever, we had the same thing over here. This just equals 9 pi squared over 8. Now, beginning to simplify, I'm going to get rid of these parentheses, distributing this negative in. And then these parentheses on this one don't really need to be here because it's plus. So now we have a pi squared over 8 and a pi squared over 8 here. So because these are both positive, I'm going to rewrite this as a 2 pi squared over 8 over here. Here we have a negative 9 pi squared over 8 and a negative 9 pi squared over 8 twice, essentially. So I could get rid of one of them and multiply the first one by 2. That will give us 18 pi squared over 8. And then so essentially, we're just adding all this together. So 2 plus 16 is 18. 18 minus 18 is 0. So this whole part of the integral, or this whole section of 3 integrals, this part actually just equals 0. So, because this equals 0, we don't have to worry about any of this. It was correct math, and we had to do this, but we don't have to worry about it. Therefore, our answer is just going to be the answer to this diagonal, which we got over here, just pi squared, so I'll just rewrite it bigger. Pi squared is our final answer. So it was really ugly, especially since we had to go through this whole process. There's probably a faster way to do it than thinking about it like that. But the way I went through it, that has to be done so you don't break any rules. But yeah, that's our final answer.